So I thought it'd be useful to work through a couple of different examples if they ask you to solve for x. Okay, so the first example here, we've got log base 3 of x is equal to 3. Okay, so 3 is my base, 3 to the power of, this is the exponent, 3 is equal to x, right? So I can take this and rewrite it into exponential form, right? The base was here, that was the 3, so 3 to the power of, and then the exponent is always here, right? So 3 to the power of 3 is equal to the answer that's on the inside, right? So 3 to the power of 3 gives me what? And so we're solving for x. Now 3 to the power of 3 is 3 times 3 times 3, right? It's 3 times itself 3 times, which is 27, if I were to work through all of that. So the answer here for x is 27. Okay. Now on the next example here, we have log base 7 of 49 is equal to x. And I want you to notice the difference between these two problems. This one had the x here, right? It wanted to know the answer, the base, the exponent, and it wanted us to know the answer on this side, right? Whereas on this one, we have the base, this is the exponent, this is the answer, right? They're always in the same place. So we have 7 is the base, x is the exponent, and 49 is that answer. Okay, so 7 to the power of what gives me 49? You might have to think through a little bit. And okay, 7 to the power of 1 is 7. 7 to the power of 2 is 7 times 7, which is 49. Okay, so the correct answer is 2. So if you need to kind of write out a few of the answers first until you can figure out what the right value is for x, you might need to do that a little bit. Okay. All right, so the next one here, I've got log base 2 of 1 over 64 is equal to x. So B here and C are very similar because the x is the thing that we're solving for on this, and that's sort of the thing on this side. It ends up being the exponent. So let me rewrite this a little bit. Okay, so we've got, move this up, here we go. So 2 to the power of x is equal to 1 over 64. Holy moly. So that might not be an easy one to sort of think through on its own, right? So we might want to actually go through and write out some of the answers, right? We know that 2 to the power of 1 is 2, and 2 to the power of 2 is 4, and 2 to the power of 3 is 8, right? And so we kind of know that if we end up with bigger exponents here, we'll just end up with bigger answers, right? And we need to make it smaller. It has to be 1 over 64. So 2 to the power of 0 is 1. It's always anything to the power of 0 is 1. 2 to the power of minus 1 is 1 over 2 to the positive 1, right? And so 1/2, that's starting to look like we're moving in the right direction. So 2 to the power of minus 2 is 1 over 2 squared, which is 1 over 4. So we're going to keep going. 2 to the power of minus 3 is 1 over 2 to the 3, which is 1 over 8. Oh my goodness, we're going to have to keep going. Let me move this. I need more room. There we go. Okay, so then we've got 2 to the power of minus 4 is 1 over 2 to the 4, which is 1 over 16. 2 to the power of minus 5 is 1 over 32. I'm kind of skipping some steps here because 2 to the power of minus 6 is 1 over 2 to the 6, which is 1 over 64. Aha, there it is. So the answer is minus 6. Now, oops, I better write here that x is equal to minus 6. So that took me a little bit of effort. The more practice you have with this, you may be able to just jump right to being able to say that it's minus 6. You certainly don't need to show all this work, but if your logs and your exponents are kind of rusty, it might take you some practice to kind of go through and figure out what x needs to be, okay, if it works out evenly. All right, moving on. So the next one here we have log base 7 is equal to x. So same idea, we're trying to solve for that exponent. 7 to the power of x is equal to 1. Okay. That's one of those tricky ones that you have to remember. What is the exponent if it's going to be equal to 1? It's hiding over here, isn't it? Right? Anything to the power of 0 is going to be 1. So in this case, x would be equal to 0. All right, so this one is going to be a little bit trickier. You might not notice that on the surface, right? Because it's still got the x over here. We're trying to solve for that exponent. So we've got, let's write it in, 8 to the power of what gives me 4. Now you might not know off the top of your head, so I might start writing out, okay, 8 to the power of 0 is 1, and 8 to the power of 1 is 8. And 8 to the power of 2 is 64. Well, and you'll notice that 4, right, that's right here, right? 4 kind of fits in right in here, right? We know that the answer is going to be somewhere between 0 and 1, but we need to actually go through and work out exactly what it is. So here's the trick. If you end up with something here that isn't going to be just a whole number, right? The trick is to, if you can, is to try to take this 8 and this 4 and rewrite them as the same base. Okay, so rewrite, maybe I'll say if possible, because it's not always possible, but if it's possible, rewrite as the same base. Okay, what do I mean by that? Well, 8, I can rewrite that as 2 to the power of 3, right? So I've got 2 to the power of 3 to the power of x. And 4, I can rewrite that as 2 to the power of 2, right? So both of them have this base of 2 now, okay? And once they both have the base of 2, now we can sort of compare them, right? Remember, your exponent rules say that we can just take these two numbers and multiply them together. So we've got 2 to the power of 3x is equal to 2 to the power of 2. Okay. And if these two things are going to be equal, right, that means the exponents need to be equal to each other, right? So that 3x needs to be equal to 2. Those are coming from these exponents, right? And then from there, now you can solve for x. So we've got x is equal to 2 divided by 3. So if it doesn't work out as a nice whole number, the trick is to rewrite them as the same base, okay? And in this case, the answer sort of makes sense. Remember over here, I told you that 4 here was in between 1 and 8, right? So I knew my answer for x had to be somewhere in between 0 and 1, those two exponents, right? And 2 over 3 is right in between 0 and 1, so my answer makes sense. Okay. Just a couple more. Okay. I wanted to go through one where the x was in the base, because that one can be a little bit trickier, or a little bit different process to actually go through and solve. So same thing as we always do, we're going to take this and rewrite it into exponential form. So I have the base is x now to the power of 2 is equal to 100. Okay, right? So I've got my base, my exponent, and then my answer, right? So once we've gotten to there, now we're going to go through and solve for x. So in this case, in order to get rid of that square, we're going to have to do plus or minus the square root, right? So in this case, our answer is plus or minus 10. So there's actually two answers that solve this equation. X is equal to minus 10 and x is equal to positive 10. And I do that one. A really common mistake is to forget the plus or minus and only to give one answer of 10, the positive 10. You have to remember the plus or minus so that this answer, x is equal to minus 10, isn't forgotten. Okay, last one here. Okay. So we're going to rewrite. We've got log base x of 27 is equal to 3 over 2. So x to the power of 3 over 2 is equal to 27. Oh, so we've got people's favorite things, right? We've got a fraction and it's in the exponent. So that's great. People love that. Okay, so in order to get rid of that to the power of 3 over 2, I want to split this into two pieces. So I'm going to rewrite that 3 over 2 as x to the 1/2 to the power of 3, because then I can do this in sort of two steps. From there, in order to get rid of that cubed, I can cube root both sides. So the cube root is going to cancel the cube on this side, and I'll have the cube root of 27. So the cube root of 27, remember I'm asking myself, what number multiplied by itself 3 times gives me 27? And the answer to that question is 3, right? From here to here, right? 3 times 3 times 3, which is 3 cubed, is equal to 27, right? So that's how I know that the cube root of 27 is 3. Then from there, in order to get rid of the 1/2, then I can square both sides, right? So if I do, we'll do it in a different color here. This side squared and this side squared. The 1/2 and the 2 cancel to just leave us with the x. And then from there, 3 squared gives me 9. Okay. So that's just an overview of some of the types of problems that you'll see when they ask you to go through and solve for x on a logarithm type problem.